Hello, my name is Maicy Lore.
And I'm Paige Lee, and our lab today is called the Water Properties Lab with Stats, where we will be testing water cohesion on a penny.
In this water properties lab, we'll be finding out how soap affects the hydrogen bonds between water molecules.
So we have multiple hypotheses for this lab, and our first hypothesis is if the hydrogen bonds can hold together when the penny does not contain soap on its surface, then when soap is put on the surface, the water may not hold together well because there is an interruption between the bonding.
And our second hypothesis is if a regular penny with no soap layer can hold a certain amount of water droplets, then the penny with the soap layer would also be able to hold the same amount of water droplets as the penny with no soap layer.
The materials needed for this lab are a penny, distilled water, soap, a beaker, a pipette, paper towels, and toothpicks.
To do this lab, pour the distilled water into the beaker, filling it about 1/4. Get a dry penny and place it on a dry paper towel. Next, by using a clean pipette, add distilled water to the penny, drop by drop, until it overflows. While adding distilled water to the penny, make sure to count the number of drops and record it on the data table that you make. Also be sure to dry the penny after every trial. Repeat this process for 5 trials. This penny experiment will be considered as our control. And this is our data table after doing 5 trials.
So for the second part of our lab, we are going to grab a little bit of soap on our toothpick and then use it to spread a thin layer of soap on the penny. Then we will use the clean pipette to add the distilled water onto the penny with soap until it overflows. And we are still counting the droplets in order to add it to our table. So before you start a new trial, be sure to dry the penny and add a new layer of soap. And here's the results from all our trials from the control group and the experimental group. And now we are going to find the average, also known as the mean. So we're going to start with our control group, and we're just going to add up all the trials and divide them by how many there was. So there was 5, and we get 33.2. We also did the same for the experimental group, and we got 11.8 as the average/mean. And now we're going to solve data table 2, which is the stats part of our lab. So we're going to find standard deviation first. We're going to take all the trials of our control group and subtract them by the mean, which is 33.2. And then we're going to square all of the differences. And then after we square them, we're going to add all of them, and we get 54.8. And then we're going to divide that by the number of trials, in this case 5, minus 1, which is basically just 54.8 divided by 4. And we get 13.7. Then we're going to take the square root of 13.7, and we have our standard deviation. We did the same for the experimental group, and we got 4. And now we are going to find the plus minus 1 standard deviation, and we're just going to take the mean from each group and subtract it by its standard deviation. And we're just doing the same thing with the experimental group. And to find 2 standard deviation, we're just going to double the standard deviations of each of the groups and subtract and add them to their means. And to find standard error, we're just going to take the standard deviation and divide it by the square root of how many trials there were. So for the control group, the standard error is 1.7. And then the standard error for the experimental group is 1.8. So to find 2 SEM, we're just going to double the standard error of each of the groups and add and subtract them to their means. So here are our final results of our stats table. We have our mean, our standard deviation, our plus and minus 1 and 2 standard deviation, our standard error, and our plus and minus 2 SEM. So to make the graph, we will use the mean and 2 SEM. And we use 2 SEM because it will ensure us 95% of the data.
And for the graph, we will just be needing the mean and 2 SEM. And the mean of the water treatment, which, as we calculated earlier, was 33.2. And the standard error multiplied by 2 of the water treatment, which is 3.4. Now you do the same for the water plus soap treatment. Now for the graph, you want to highlight just the treatment and the mean, and then go to Insert and Insert Chart. There you have your chart, and now you want to customize it. First, we're going to fix up the setup. So go to Setup, scroll down, and select Switch Rows/Columns, and select Use Column C as headers. Then unselect Use Row 2 as labels. So now your graph will be looking like this. And now you want to go to Customize, and just customize your graph, and we'll be first changing the title. So go to Chart and Axis Title, select that, and under that there is a title type selector. You want to select that, and we'll be changing the chart title first. And I will just be renaming that as mean number of droplets of distilled water on a penny with and without soap. So this title kind of basically defines our lab in a whole. Then you want to go back to your title type selector and select chart subtitle. And for the subtitle, I'll write or explain about the error bars that we'll be adding on later on. And I'll write that error bars represent 2 SEM with a 95% confidence. Now you want to go back to your title type selector and select horizontal axis title, which I will name as our treatment because it is just our 2 treatments on the axis. And then go back to your title type selector and select vertical axis title, which I will rename as the mean number of droplets on penny. We will want to add error bars, and to do that we will still be under customize. Right under it there is a series. You want to select series, go down, and there is error bars. Select error bars and then scroll back up. So there's apply to all series, this series selector, and you have the option between water and water plus soap, but we'll be adding error bars to our water treatment first. So select the water, scroll back down, and you want your type to be on constant. And for the value, it would just be our 2 SEM that we calculated for the water treatment, which is 3.4. There we have our error bar for the water treatment. To do the error bar for the water plus soap treatment, you want to scroll back up, and as we clicked on here for the series selector, click on it and select water plus soap. Scroll back down and change the type again to constant. And as I said earlier, the value is just a 2 SEM they calculated earlier, and for the water plus soap treatment, it was 3.6. So now you have your whole graph done with all the appropriate titles and labels as well as the error bars.
So by looking at our graph with the error bars, since the error bars do not meet with each other, this means our data is significantly different. Which does support our first hypothesis that if the hydrogen bonds can hold together when the penny does not contain soap on its surface, then when soap is put on the surface, the water may not hold together well because there is an interruption between the bonding.
That is the water properties lab with stats. From our lab data and graph that we made from our lab data, we conclude that soap weakens the hydrogen bonds between water molecules because within the penny with the soap layer trial, there were less droplets compared to the penny with just water. Soap breaks cohesion, weakening the hydrogen bonds between water molecules, disrupting with that and thus causing less strength to hold hydrogen bonds together. Experimental errors can happen though, and we will list some possible experimental errors that could have occurred in our experiment. First, we could have had non-consistent soap layers every new trial by not applying the same amount of soap layers, which can affect the amount of water droplets that occur during that trial, either significantly having more than the other trials or less than the others. Secondly, we could have affected the amount of droplets on the penny due to the difference in our pressure squeezing the pipette. If the pipette is squeezed harder and the droplets falling onto the penny is faster, then the water droplets get smaller. If the pipette is squeezed softer, the bigger the droplets of water will be, and thus creating a drastic difference in the amount of droplets possible on the penny per trial. Thirdly, the high consistency of where you are pipetting your water from also matters, as it will vary depending on how high or low you are from the penny. The higher you go, the more surface area from the distilled water that will cover the penny as it splashes from above. Overall, you want to be consistent with all your trials as best as possible to lessen experimental errors.